to True Projects. In this video, we are going to explain about a project titled Comparison of Machine Learning Algorithm for Predicting the Crime Hotspots. The project's introduction emphasized the rapid increase of data concerning public security in recent times. The project's main goal is to investigate the crime prediction, specifically in the areas of crime risk and crime hotspot. It is noted that many predictive models rely solely on historical crime data for calibrating these models. The objective is to evaluate and compare the predictive performance of various machine learning algorithms in identifying the crime hotspot. The research utilized historical data on public property crime from a specific area in a large coastal city in China. The goal is to assess the effectiveness of different machine learning algorithms in crime prediction and examine the influence of built environment covariates on the predictive accuracy of these models. The project seeks to offer valuable insight into the efficacy of machine learning algorithms for crime prediction and recommends the incorporating both historical crime data and covariates aligned with criminal theories in future crime prediction endeavors. The basic requirements that are needed to build this project. Hardware requirements are operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement Python IDE with version of 3.7. These are the modules that are developed to build this project. The first module is upload the crime dataset. This module allows to upload a crime dataset to the application. And the second module is pre-process the dataset. This module focuses on pre-processing by converting the non-numeric data into the numeric format and converting the necessary because machine learning algorithms typically accept only numeric format. The third module is run SPM algorithm. In this module, the support vector machine algorithm is trained on the pre-processed dataset with commonly used for classification tasks. It makes predictions on the test data. And the fourth module is run KNN algorithm. This module involves training the k-nearest neighbor algorithm on the pre-processed crime dataset. And here KNN is used for the classification and regression task. It predicts the labels of the test data based on the proximity to its neighboring data points. And the fifth module is Run Random Forest Algorithm. This module focuses on training the random forest algorithm on the pre-processed crime dataset. And the random forest is an ensemble learning method that combines multiple decision trees to make the predictions, and it is a powerful algorithm for classification and regression tasks. And the sixth module is Run LSTM algorithm. In this module, the long short-term memory trained on the pre-processed dataset is a type of recurrent neural network that is particularly effective for sequence prediction tasks. And the final module is hit rate comparison graph. This module compares the hit rates obtained from the different algorithms used in the previous model. It plots a graph that visually represents the hit rate comparison. This graph allows for easy comparison and evaluation of the performance of each algorithm. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of the dataset folder, and this folder consisting of the Python file, and the model folder consisting of .h5 files which contains the algorithm information, and these can be used at the time of execution of the project and directly loaded into it. And the crime hots prediction and the test is the Python file, and run is a bat file. Instead of executing the program and this file, we used the command line interface for this. Double click on run.bat file. Here this is the graph where x-axis represents of the location names and the y-axis represents the number of crimes happened in that location, and close this graph. And this is a graph where the SPM model algorithm is generated on the pre-processed dataset where x-axis represents the days and the y-axis represents the number of crimes, and the red line represents the original crime rate and the green line represents the predicted rate. In this graph, we can see there is much gap between the original and predicted rate, so algorithm performance is not good. And then close this graph. And here the KNN algorithm model is generated, where x-axis represents the crime location and the y-axis represents the forecasting crime location. Here the red and green line is off with little difference. Hence, the performance of this model is high compared to that of the previous model. And close this graph. Here, the random forest algorithm is generated, where x-axis represents the original observed crime location and the y-axis represents the forecasted crime location. Here the red line represents the observed crime location and the green line represents the predicted line location. And here the Descartes hit rate compared to that of the previous models. And then close this graph. And here this is the graph where LSTM algorithm is generated, where the x-axis represents of original observed crime location and the y-axis represents of forecasting crime location. Here red line represents of observed crime location and the green line represents of predicted crime location. Here the difference between these lines are very less, and this way we can say that this model is giving and most accuracy when compared with the other algorithms. And close this graph. And here this is the hit rate comparison graph, where x-axis represents the algorithms we used and the y-axis represents of the value assigned for the each algorithm's accuracy. And close this graph. In conclusion, the project provides insights into the effectiveness of different machine learning algorithms for crime prediction and highlight the importance of incorporating the covariates associated with criminological theories in future crime prediction models.
For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.